I'm Paul Bandlow. I'm a senior principal at WJE, and we've been involved with the lift span of the bridge, particularly the mechanical electrical aspects of the lift span, for more than 10 years. And during that period, we've had various assignments to make sure that the bridge remains in good condition and reliable operating condition. Um, some of that includes mechanical investigations, mechanical inspections, electrical inspections. We've also done span balance testing. One of the more important things we've done with regard to the safety of the bridge is trunnion, ultrasonic, and magnetic particle inspection. So what you see pictured here, those are what we call the trunnions. They're large pins that support the entire weight of the bridge and the counterweight when the bridge is in operation. So they're obviously critical to the safety of the bridge. And that inspection includes ultrasonic, which is a way to look inside of the trunnion, if you will, to look for internal defects. We've also done magnetic particle testing, and that scans the surface of the trunnion to look for cracks. And that testing was done in 2016 and again in 2021. And each of those times we found no evidence of cracks in the trunnion. So they are in good condition. The surface of the trunnion is also in good condition. The last inspection we did was in 2024. That was a mechanical electrical inspection, and that's due. The next mechanical and electrical inspection will be due next year in 2026, as well as the trunnion. We would ultrasonically test the trunnions again in 2026, again to make sure that they're suitable for continued operation and the safety of the bridge. So what do we do in terms of mechanical electrical inspection? Primarily, they're mostly visual in nature, but we do some other things as well. On the mechanical side, it's a visual inspection of the span drive machinery, the counterweight ropes, the span logs, live load supports. Those are the bearing points for the bridge, as well as the span and counterweight guides. We do operational testing of the bridge. The bridge is operating several times, and we observe the various systems are operating as part of the inspection. And we take measurements of bearing and gears to document wear. On the electrical side, it's visual inspection with operational testing. We also record electrical parameters, including voltage and current, to see if the condition of the motors and to see the loads on the motors. We do something called mega testing, which is an insulation resistance type testing. And what that does is it determines the insulation resistance levels on the wires. And by looking at that information, we can determine the remaining service life of main feeder cables and motors on the bridge. And the last thing we do is what's called an operational sequence interlock test. The bridge has specific safety features which prevent the machinery from being operated out of order. For instance, in order to raise the bridge, the traffic gates need to be down, and we verify that all of those interlocks are in place as part of the electrical inspection. In terms of findings, generally the bridge is in good condition mechanically and electrically. There are some things that are dated, but there are no critical findings. On the mechanical side, the bridge does not seat consistently, so sometimes when it comes down, there's a slight gap at the live load supports, which means the bridge will move slightly under the live load of traffic, but it's not a huge concern, but it is something that should be corrected. We've got some machinery enclosures that are in poor condition at the top of the tower that need to be corrected. We found water in the gearboxes at the top of the bridge for the span drive machinery. And in that case, it's simply a matter of changing the oil in the gearboxes. And there's some shiv cover winches that are in poor condition and need replacement. These are the winches that allow for the covers to be removed or raised so that we can inspect portions of the shivs. And the shivs are the large wheels, if you will, at the top of the towers. On the electrical side, the seating control sequence needs to be modified, and we believe that will help with the seating of the bridge. There are some wire nuts that are in violation of AASHTO. And typically wire nuts are something that may be commonly used in residential construction, but they're not acceptable to AASHTO, so it's not a huge concern here, but they should be replaced and the wires properly terminated. And then we have some unlabeled wires in junction boxes And this will only be a problem in the event if there's an issue with the bridge and you need to do troubleshooting with wires that aren't properly documented. It can make troubleshooting more difficult. So overall, there are really no significant findings, and we'll continue to work with the port to improve the condition of the bridge. In terms of bridge operations, we have recommended that the bridge be operated monthly. These are primarily maintenance operations. As you may know, there aren't very many operations for marine traffic these days. And we've suggested those operations be conducted during off hours to limit disruptions to the traveling public. The purpose of these operations is to distribute lubrication, but also to keep staff familiar with the operating procedures of the bridge. In terms of making sure that the staff is up to speed with operating procedures, we recently conducted training, and that was done just a couple of weeks ago, and that was done by our electrical personnel. And in order to keep the bridge operating reliably and make sure each operation is as reliable as it can be, we've arranged for our electrical staff and the staff from Panatrol, who are the systems control people, to be on the phone as backup to the port during all bridge operations. And in support of that, the cell phone coverage on the bridge was recently upgraded so that we have better access to the bridge. And if there is a problem in a bridge operation, we can see what's going on and we can direct the port to take the necessary steps to get the bridge back down safely. And with that, I'll turn it back to Michael.